Pythagorean theorem is very old. It relates the length of sides in a right-angled triangle. So you can't use this thing unless you see a box there. Right? It means that this side and this side are meeting at 90 degrees. If you have a triangle like that and you label the sides A, B, and C, C gets a special name because it is the one across from the 90-degree corner. So if you look, right, they are not touching each other. This one here is called the hypotenuse. All right. So those three letters, right, those two sides are arranged like this. C squared is A squared plus B squared. So if I knew A and B, I could calculate C. If I knew C and A, I could calculate B. If I knew B and C, I could calculate A, etc. Just using this basic relationship. So I might as well put some numbers on, give it a try. Let's say that B is 8 and A is 12. All right, well, C then, C squared, would be 12 squared plus 8 squared. 12 squared is 144. 8 squared is 64. And 144 plus 64 would be 208. So to finish then, I just need to break the square on this. So C would be, technically when you break a square, you need to use plus or minus square root. So plus or minus. 208 doesn't go cleanly, so I'm going to need my calculator here. 14.422. So case 1, C is 14.422 units, whatever this is measured in. Case 2, C would be negative 14.422. Now that one, and when you get going, you're not even going to write this one down because it's never going to work. But in algebra, you're supposed to consider all the options. This particular one requires you to have a negative length or an unlength. I don't know what that means. So we're just going to reject that solution, rejected. By the context of the question. And I mean, the context of the question is that the side has to actually be positive because you can't have negative lengths in a real space. Okay, so if you know A and B, you just plunk them in, carry out the operations according to Bedmas, and you end up with your answer. I'm going to clear this off. We're going to try one where we're finding either A or B. All right, so we've got a triangle there. First thing I'm going to check is, does it have a 90-degree corner? And it does. So as soon as I have a 90-degree corner, I can use my Pythagorean theorem. Then you just have to be very careful about which numbers go in for which ones. So first off, I'm going to find my 90-degree corner, and I'm going to look across from it. The side I find there is the hypotenuse, which in this particular formula is my C value. So in it goes. Now, which one's A, which one's B? It turns out it doesn't matter. So I like to lead with numbers, so I see a 7 there. I'm going to put a 7 in for A, and then the other one will be my unknown side. Okay, so I can square 20, that's 400. I can square 7, that's 49. Can't square x because I don't know what x is yet. And I can't add 49 to x squared because I don't know what x squared is. So now I have to flip into algebra mode to try and push all the numbers away from the letter. So I see a 49 here being connected to that with addition. So I'm going to subtract 49 from both sides. That leaves me with 351 on the left and x squared on the right. We break an x squared with the square root, plus or minus. And square root 351. You get 18.735. So case 1, x is 18.735, and case 2, x is negative 18.735, which we're going to reject by context. So this side here must be 18.735 units, whatever the units they're measured in. The only way for a length of 7 and a length of 20 to meet at a 90-degree corner is if this side is 18.735 units long. And that's it for Pythagorean theorem. You're either solving for the hypotenuse or you're solving for not the hypotenuse. If you're solving for the hypotenuse, you just park the numbers in and do it. If you're solving for not the hypotenuse, you're going to have to take this chunk out in order to get down to some of your algebra we'll work on. I think that's it. You're good to go for the practice problems.